kiddos. We're going to start our trig unit today, and we're going to start with a basic review of the Pythagorean theorem and your two special right triangles, the 45, 45, 90 and the 30, 60, 90. Now these worksheets are found on your haiku page, so if you could download those, you'll be able to look at them when we're finished. Just make some good notes as you go along, okay? So, I'm sorry I'm having to teach it through here. I thought it would be easier for you from worksheets instead of PowerPoints. So hopefully this will help you out a little bit. All right, so starting with the Pythagorean theorem. This is one of our favorite theorems because everybody always remembers it. Okay, we have a squared plus b squared is equal to c squared. Now remember the important things about a right triangle. In a right triangle, the two sides that form the right angle are going to be your A and your B. Those are your legs. The side that's directly across from the right angle, that's your hypotenuse. That's going to be C. C has got to be the longest length in your right triangle. A and B, they have to be less than C in their value. So I'm just going to, like I said, give you a quick run through of the Pythagorean theorem and make sure that you remember what to do. So let's look at number one. On number one, I noticed that I've got 4 and 8. 4 and 8 are my legs. The reason that I know that is because those are the two sides that form the right angle. Now, directly across from the right angle is my x, so that's going to be my hypotenuse. X has got to be greater than 4, and it has to be greater than 8, because those are the two lengths that we have for our sides. So when we're plugging into this, we're going to write down our formula. A squared plus b squared is equal to c squared, and we're going to plug in a and b. And then from there, we'll just work everything out. Okay, we know that a squared or 4 squared is 16. B squared or 8 squared is 64. And that is going to equal c squared. Let's go ahead and add 16 and 64 together, and that's going to give me 80 is equal to c squared. But remember, we're not interested in c squared. We need c, which is the length of our hypotenuse. So let's undo the square by taking the square root. And we get c is equal to the square root of 80. Now, the square root of 80 is something that we're going to have to try and simplify. When you deal with these radicals, always make sure the radicals are in simplest form. So if you think about 80, we know that it has factors of 1 times 80, 2 times 40, 4 times 20, and 5 times 16. I'm not going to go any further because 5 is a prime number and 16 is a perfect square. So when I replace the square root of 80 with 5 times 16, I can take the square root of 16 and I'll get my c value as 4 square roots of 5. So this doesn't look very pretty on this worksheet. Hopefully you're working it out on a nice piece of paper so that you would have some more room to move around and write all this out. But do you notice that I wrote down my formula? I plugged into my formula and then I worked everything out from there. Once I was finished, if you have a radical answer, make sure that you simplify your radical. Now, from all of the previous problems that we have done, when we took the square root here on both sides, we had to do a positive and a negative in front of our radical. With this being the length of the side of a triangle, we're only going to use the positive value for our radical. So c is going to be 4 square roots of 5. And that's it. We're done with that. Okay? So that one wasn't so bad when we're actually finding the hypotenuse given the two legs. But take a look at number 2. If you look at number 2, you're going to see we're not looking for the hypotenuse this time. We are given the hypotenuse. We are actually looking for one of the legs this round. So let me erase this and let's see what we can do with this one. Okay, so once again, I'm going to write down my formula. A squared plus b squared is equal to c squared. So right across from my right angle is my hypotenuse. This is my hypotenuse. That is my c. Okay? So let's plug in. I've got a leg here and a leg here. So which one should be A and which one should be B? It doesn't matter, okay? You just pick one to go for A and pick the other for B and then go for it. C is pretty important, isn't it? So the hypotenuse is the only number that can go in the place of C. But your legs, those two values are interchangeable, okay? So what we're gonna do on this one, I like to solve for A when I'm looking for a leg, so I'm gonna leave it as A. So I have A squared plus B squared. I'm gonna let my leg equal 22. And it'll equal C squared, which is my hypotenuse, directly across from my right angle. That'll be my 24 squared. Okay, so I'll have A squared is plus. Now let's go over here to our calculator. That is not it. We'll have 22 squared. And we're also going to have to do 24 squared. So we'll have 484 and 576. So 484 and 576. Now, if you don't have a calculator at home and you don't like using the calculator on your phone, you can always go to Desmos, www.desmos.com. And on the front screen, when you get there, up here is your graphing calculator function. You don't need those right now. Right here, you can get a 4-function calculator or a scientific calculator. And if you click on scientific, you'll have a scientific calculator to pop up. But again, that's Desmos, DESMOS.com. You've seen me use it in class several times before I got this calculator. But if you have a basic 4-function, you should be okay right now. All right, so let's go back to this problem and let's see what we've come up with. So 22 squared is 484 and 24 squared is 576. If we're going to solve for A, we've got to get A by itself. So that tells me that I've got to subtract away this 484 from both sides. So now 484 minus 484 cancels out, and that's going to leave me with A squared on the left. Over here on the right side, I've got to subtract now. I've got 6 minus 4, which is 2, and then I've got 7 minus 8. I can't do that, so I'm going to borrow from the 5 and make it a 4 to make my 7 a 17. So now I have 17 minus 8, which is 9. So 576 minus 484 is equal to 92. Let's figure out what our leg value is going to be by taking the square root on both sides. Let's see what we can do about simplifying 92. We've got 2 times 46. 3 won't go into that. 4 will. 4 and 23, that's a pretty good value right there because 23 is prime and 4 is a perfect square. So let's replace 92 with 4 times 23. The square root of 4 is 2, and then 23 is going to stay under the radical. So that tells me that my A is going to equal 2 square roots of 23. And again, I'm using the positive value because it's the length of the side of one of my triangles. You don't want a negative length on your triangle side. So on the first problem, I found the hypotenuse C. A and B interchangeable, whichever one you want to put in A and whichever one you want to put in B. On number 2, I was given the hypotenuse. I'm looking for one of the sides, okay? So I always like for my leg to be A that I'm solving for because it's in the front and that just makes me more comfortable. If you want to put your 22 here and solve for B, you're going to get the exact same answer. A and B are interchangeable, so it's no big deal. So after I finished all that out and I got down to A is equal to the square root of 92, I went over here and listed the factors of 92, and I'm looking for a perfect square and a prime, or I'm looking for a perfect square and a number that doesn't have any perfect square factors other than 1. They're not always going to be prime, but if they are, it's pretty nice. So I ended up with 4 times 23 because 23 is a prime number. And so from there, I took the square root of 4, which is 2, and left 23 under the radical, and I got the length of my side to be 2 square roots of 23. okay? So that covers a very, very, very quick review of the Pythagorean theorem, okay? So the next thing that we want to look at is actually going to be our special right triangle relationships, the 45, 45, 90, and the 30, 60, 90. Students often forget these, okay? So make sure that you take really good notes on these triangles. Let me scroll this up so that we'll have plenty of room. All right, so let's get started with the 45, 45, 90. In a 45, 45, 90, this is going to be an isosceles triangle. It's going to have two congruent sides. This, of course, has got to be the hypotenuse. But these other two sides, they're going to be congruent to one another, okay? Knowing that the hypotenuse has got to be the largest side, and if the two other sides are congruent, what we can do is we can allow these two sides to be x. Now, the special relationship for that is going to be right here. The hypotenuse is x times the square root of 2. And by multiplying x by the square root of 2, that's going to make it larger, okay? Where does that come from? Well, if you let your two legs be x, okay, you can have a squared plus b squared is equal to c squared. So that's going to be 2x squared is equal to c squared, okay? So if you take the square root on both sides, the square root of x squared is x. You can't take the square root of 2. So you end up with c is equal to x square roots of 2. And so that's where the hypotenuse comes from, okay? So in a 45, 45, 90 triangle, the two legs are both going to have a value of x, and your hypotenuse is going to have a value of x square roots of 2, okay? Now, in a 30, 60, 90, this is another one of your special relationships. But in order to work this one, you need to also think back about what you learned about angles and the sides opposite of those angles. So look at this right here. You've got a 30-degree angle, a 60-degree angle, and a 90-degree angle. Directly across from the 30-degree angle, since 30 degrees is your smallest angle, the side opposite of that angle is going to be the shortest side. So 30 degrees is the smallest angle. This right here is going to be the shorter side, or the shorter leg. Now 60 degrees is your middle angle, isn't it? So directly across from 60 degrees is going to be your longer leg. We'll put LL there for that. And then we already know that directly across from the right angle, that's your hypotenuse, okay? Biggest angle, biggest side. Okay, so the shorter leg, how are we going to come up with patterns for these? Again, through your Pythagorean theorem. Let me go ahead and erase this right here so I have my room back. With the 30-degree angle, since it's the shortest side, we're going to let that equal x, okay? The 60-degree angle, our middle value or our longest leg, we're going to let that one equal x times the square root of 3. And then across from the right angle, our hypotenuse or our biggest side, that one is going to equal 2x. So our shorter leg across from the 30-degree angle is going to be x. Our longer leg across from the middle angle value, which is 60 degrees, is going to be x times the square root of 3. And then our hypotenuse, which is directly across from the right angle, is going to equal 2x. Okay? So with that being said, let's look at these values. And let's work some of these problems out. Okay, now 3, 4, and 5, all three of these are 45, 45, 90. So 45, 90, that means this one also has to be what? 45 degrees. Okay, so we'll use x, x, x square root of 2 pattern. With that being said, let's see what we've got. across from the 45-degree angle right here is 10. So across from the 45s, those are going to be our congruent sides, aren't they? Okay, so this side and this side should be congruent. This right here, this is my hypotenuse, okay? So it's got to be the longest side, or x square roots of 2. So I see that this side is 10, so that means that this side should also equal 10, shouldn't it? So that tells me that x is equal to 10. Now I need to find out what my hypotenuse is. So if I know that x is equal to 10, I know the hypotenuse is going to be x times the square root of 2. Well, I already know that x is equal to 10. So I'll replace x with 10, and I'll get my hypotenuse as 10 square roots of 2. Let's look at number 4. We have 45, so that means that this also has to be 45. Figure out the two congruent sides in the hypotenuse before you jump in and start solving everything. So 45, 45 tells me that these two sides right here have to be my congruent legs. Across from the 90-degree angle is my hypotenuse, which is, in this case, 16. So 16 is my hypotenuse. The hypotenuse has got to equal x square roots of 2. Everybody see how I got that? This is the value of the hypotenuse. The hypotenuse has got to equal x square roots of 2. So I'm setting 16 equal to x square roots of 2. When I do that, I can solve for x, and I'll know the length of my two congruent sides, which will be x and y. But they're going to be the same because it's a 45, 45, 90. Now, solve for x by dividing by the square root of 2. These two will cancel out, and I've got x is equal to 16 over the square root of 2. Well, one thing that I know is I cannot have a radical in the denominator of a fraction. That's a huge math no-no. So in order to get rid of this square root of 2, I'm going to rationalize the denominator, which means I'm going to multiply it by 1. But my 1 is going to be a special 1. It'll be the square root of 2 over the square root of 2. So now I have the square root of 2 times 16. That's going to be 16 square roots of 2. Because when you have a radical times a number, you can't bring that number into the radical without squaring it. And you don't want to do that. So just multiply 16 times the square root of 2 and just leave it just like this. Now notice the square root of 2 times the square root of 2, those are both under the radical. You can multiply those together because they're both on the inside. The square root of 2 times the square root of 2 is equal to the square root of 4. Well, what is the square root of 4? The square root of 4 is 2. Because when you multiply a radical times itself, your radicand, which is the number under the radical sign, is going to be your answer. See, the square root of 2 times the square root of 2, it equaled 2, didn't it? So now I have 16 square roots of 2 over 2. Well, both of these numbers are outside the radical, aren't they? So I can simplify these two numbers as well. So 2 will go into 16 8 times, and I end up with 8 square roots of 2. Okay? So that means x is 8 square roots of 2. And if x is 8 square roots of 2, then y is also 8 square roots of 2, because these two sides must be congruent. Okay? So 8 square roots of 2 and 8 square roots of 2. All right, so we have one more 45, 45, 90. It gives us, once again, the hypotenuse. So you're going to have to do exactly what I just did, okay? So 14 square roots of 2 equals x square roots of 2. Figure out what x is. Once you figure out what x is, that's going to be the length of your two sides, okay? So right now I want you to pause the video and I want you to work out number 5. And then mash play and watch me work it out. And let's make sure we got the same thing before we move on to the 30, 60, 90. So number 5, that's your problem right now. All right, let's see how you did. Directly across from the hypotenuse, we have 14 square roots of 2. So I know the hypotenuse value is x square roots of 2. So set it equal to the hypotenuse here, which is 14 square roots of 2. Solve for x. That's going to be the length of your two sides. So let's divide both sides by the square root of 2. Now, when I divide the square root of 2 over the square root of 2, those two cancel out, giving me 1. So I have 14 times 1, which is 14. This was very simple, wasn't it? You didn't have to do anything with radicals because they canceled out. So if x is equal to 14, so is y, okay? So that gives you your 45, 45, 90. Just remember, if you are given one side, set it equal to what it's supposed to be, okay? You know that these two sides are congruent, so both of those are your x's. Your hypotenuse, the longest side, has to be x square roots of 2. So if you're given the hypotenuse, set it equal to x square roots of 2 and then solve for x. You're going to have to rationalize some denominators. You're going to have to simplify radicals here. So if you have any trouble with simplifying radicals or rationalizing a denominator, you need to send me a message and I'll get some materials together for you to work on that on your own, okay? And then I can help you separate from class. All right, so those were your 45, 45, 90s. Now what we want to do is look at your 30, 60, 90s. Those are going to be a little bit more work than the 45, 45, 90. So let me scroll this up just a little bit so that we can look at 6, 7, and 8. Okay, so when I have a 30, 60, 90, fill in what you know. All right, this one's 30, this one's 90, so this angle has got to be what? 60 degrees, right? Okay, so I know across from my 30-degree angle, the side length is equal to x. I know across from my 60-degree angle, it's x square roots of 3. And I know across from my 90-degree angle, it's 2x. So let's see what value that I'm given. So here is my value. I've got a side length of 8. As I look, I see that that's across from my 90-degree angle. So I know that 8 is my hypotenuse. So what is the number for the hypotenuse? It's 2x, isn't it? So if 2x is equal to 8, I can solve for x by dividing both sides by 2. And I'll get x is equal to 4. X is going to be the side length across from the 30-degree angle. So here's my 30-degree angle. Let's go ahead and put this lovely little 4 right here. Okay? So now I need to find what's across from my 60-degree angle. With my 60-degree angle, I get x and multiply it to what? The square root of 3. So if x is 4, to get y, I'll simply multiply 4 times the square root of 3. How easy was that? So now I know that x, which is across from my 30-degree angle, is equal to 4. And I know that y, which is across from my 60-degree angle, is 4 square roots of 3. Because across from the 30 has to be plain old x. So when I solved this and got x equals 4, that was it. That's the side length across from the 30-degree angle. Now the 60-degree angle has to be x square roots of 3. So whatever you get for x right here, multiply it to the square root of 3, and that is going to be the side length across from your 60-degree angle, okay? How did I get x in the first place? Well, let's review that. I was given the hypotenuse, and knowing the hypotenuse is 2x, I set 2x equal to 8. And then I solved for x, which is going to be the value across from my 30-degree angle. Isn't that great? Okay, so looking at all that, take a moment and soak it in, and then we're going to do this one over here. Okay, it's not looking so easy, is it? Okay, let's see what we can do with this. All right, kiddos, let's figure out what we got here. We got a 60 degree, a 90 degree, so that tells me that this one right here is my 30 degrees, isn't it? So with that being the case, I know across from 30 degrees has got to be what? X. I know across from 60 degrees, which is what I've got, that one's got to be x square roots of 3. And then my 90 degree angle, that's my hypotenuse. So 90 is equal to 2x, okay? So what I've got to do, I've got to figure out what x is so that I can figure out any of the other measures. Because you notice the 30, the 60, and the 90, they all revolve around x, don't they? They just have something multiplied to the x. So let's see what we got. We got the number across from the 60 degrees, which is 27. So 60 degrees is x square roots of 3. So I'm going to take my x square roots of 3, and I'm going to set it equal to my 27, because that's the length of the side. Okay, now let's solve for x. To do that, I'm going to have to divide both sides by the square root of 3. That way the square root of 3 over the square root of 3 will cancel out to 1, and that's going to leave me with x. Over here, I've got 27 over the square root of 3. That's a disaster. I cannot have a radical in the denominator. So let's multiply by the square root of 3 over the square root of 3. 27 times the square root of 3 is exactly that. Because this one's outside and this one's inside, just multiply them together and get 27 square roots of 3. The square root of 3 times the square root of 3 is the square root of 9. What is the square root of 9, people? That will give us 27 square roots of 3 on the top, and the square root of 9 is 3. Now look at this. Both of these numbers are outside the radicals, so I can divide those. 3 will go into 27 9 times evenly. And that's going to give me 9 square roots of 3 for my x. My x is going to be the side across from the 30 degrees, which they have labeled as y. So y is 9 square roots of 3. Now we need to figure out what the hypotenuse is. The hypotenuse has to be 2 times x. Well, I found that to be 9 square roots of 3. So I have to multiply 2 times 9 square roots of 3. 2 times 9 is 18, giving me 18 square roots of 3. This is my hypotenuse, which they have labeled as x. Don't worry about the x's and the y's on their triangles. You figure out the values and then plug it into the correct value that they have for you, okay? So with that being said, look at number 8. We've got x, which is going to be my hypotenuse. We've got y, which is going to be across from my 60 degrees. We are given 5 square roots of 3, which is going to be my 30 degrees. So right now, pause the video and work out number 8. All right, let's see how you did. Okay, so I know if I've got a 60 and a 90, this one right here is my 30-degree angle. So across from my 30-degree angle is my x. Remember, everything revolves around that x, doesn't it? So if this is my 30 degrees, which is my x, remember my 60 degrees is x square roots of 3, and my 90 degrees is 2x. I have x. So the other two, they're going to be a breeze. So if x is equal to 5 square roots of 6, then to find my side across from the 60 degrees, I have to take x and multiply it times the square root of 3. So that means I'm going to take 5 square roots of 6, and I'm going to multiply it times the square root of 3. The 5 on the outside will stay on the outside. But here, these two radicals, I can multiply those together to get 5 times the square root of 18. make sure it's in its simplest form, which we know it's not, because you have 1 times 18 is 18, and 2 times 9 is 18. 9 is a perfect square, so I'm going to be able to simplify that. So if I put 2 times 9 under my radical, the square root of 9 is 3. So that 3 is going to come outside with the 5 that's already there. 3 times 5 is 15, giving me 15 square roots of 2. Now this is going to be across from my 60-degree angle, which they have labeled as y. So 15 square roots of 2. Now let's figure out what x is. X is my hypotenuse, isn't it? So the hypotenuse is found for 2 times x. Okay? 2 times x will be 2 times 5 square roots of 6. 2 times 5 is 10, giving me 10 square roots of 6 for my x on this triangle. So my two solutions are 10 square roots of 6. This is going to be my hypotenuse. And 15 square roots of 2. This is across from my 90-degree angle, or 60-degree angle. I apologize for that.